400 million miles from where you're sitting, there's an ocean nobody has ever seen. It's buried under 20 miles of solid ice, on a moon most people have never heard of, and it holds more water than every ocean on Earth combined, twice over. No sunlight has touched it in 4.5 billion years. No wind has ever rippled its surface. And yet NASA believes this pitch-black, alien sea might be the single best place in the entire solar system to find life beyond Earth. Not Mars, not some planet trillions of miles away. A moon of Jupiter called Europa. Stick around, because by the end of this video, you'll understand why scientists are so obsessed with a world we've never actually touched. And if mysteries like this fascinate you, hit like and subscribe. It genuinely helps this channel keep exploring the universe with you. For most of human history, Europa was nothing more than a faint point of light. Galileo Galilei spotted it in 1610, one of 4 moons circling Jupiter, and for over 3.5 centuries, that's all it was. A dot. It wasn't until the space age that Europa finally revealed a face, and when it did, that face was strange. In 1979, 2 Voyager spacecraft swept past Jupiter and its moons, snapping the first close-up photographs of Europa ever taken. What came back stunned the scientists analyzing the images. Europa wasn't scarred and battered like most moons in the solar system. Our own moon, Mercury, even Jupiter's other large moon Callisto, they're all pockmarked with craters. Evidence of billions of years getting hit by space debris. Europa had almost none of that. Its surface was smooth, bright, and covered in strange reddish-brown lines crisscrossing the ice like cracks in old porcelain. One planetary scientist working on the Voyager mission described Europa's terrain as looking almost unnervingly young, like something kept resurfacing it and wiping the slate clean. And that raised an obvious question. If impacts happen everywhere in the solar system, why does Europa look like it's had a facelift? Something down there was erasing the evidence. But what? Those strange lines running across the surface, scientists later named them lineae, and some of them stretch for over 1,000 miles. When researchers studied them closely, they noticed something remarkable. If you took the edges of certain cracks and slid them back together, they matched up almost perfectly, like puzzle pieces that had been pulled apart and shifted sideways. This wasn't random damage. This looked like plates of ice actually moving, splitting open and filling back in with darker material rising from below. In some regions, the ice looked outright chaotic. Blocks the size of small towns appeared broken, tilted, and refrozen at odd angles, floating in a frozen slurry like ice chunks in a half-melted drink. Scientists started calling these areas chaos terrain, and the name stuck because there was really no better word for it. The only reasonable explanation was that something warm, or even liquid, had been moving underneath, breaking the crust apart from beneath before it froze solid again. So by the early 1990s, a radical idea was gaining traction. What if Europa wasn't a solid ball of ice at all? What if there was an ocean hiding underneath the frozen shell? That idea moved from wild speculation to genuine scientific consensus once NASA's Galileo spacecraft arrived at Jupiter in 1995. Galileo spent years orbiting the planet, and every time it swung past Europa, it gathered more evidence. It measured the moon's gravity field precisely enough to calculate its internal structure, and the numbers fit a layered world. A rocky interior wrapped in a shell of water, not solid rock all the way through. Then came the real smoking gun. As Galileo flew through the space around Europa, its instruments picked up something odd happening to Jupiter's enormous magnetic field. Right near the moon, that field was being disturbed, almost as if something inside Europa was generating its own magnetic response. The most convincing explanation was that Europa contained a layer of electrically conductive material shifting and swirling beneath the surface. And the best candidate for that conductive layer? A global ocean of salty water. Think about that for a second. Scientists confirmed the existence of an alien ocean not by drilling into the ice, but by watching how a distant moon bent Jupiter's magnetic field around itself, the way a hidden magnet might tug at a compass needle from inside a locked box. Naturally, this raised another question. Europa sits nearly 500 million miles from the Sun, in a region so cold that surface temperatures hover around -260 degrees Fahrenheit. So how on Earth, or rather how on Europa, could there possibly be liquid water down there? The answer lies with Jupiter itself. Europa doesn't orbit alone. It's caught in a gravitational dance with two other large moons, Io and Ganymede, locked into a rhythmic pattern where their orbits repeatedly line up. Every time Europa swings closer to Jupiter, the planet's massive gravity stretches the moon slightly out of shape, flexing its icy crust by as much as several dozen yards. Then, as Europa moves farther away, it relaxes back. Closer, stretch, farther, relax. Over and over, forever. That constant flexing generates friction deep inside the moon. The same basic principle as rubbing your palms together quickly to warm them up on a cold day. Except here, it's not palms, it's an entire moon being kneaded by a planet 300 times more massive than Earth. That friction produces enough heat to keep a vast layer of water liquid, even trapped beneath miles of ice, in the freezing depths of the outer solar system. Jupiter, in a very real sense, acts as Europa's furnace. Current estimates suggest the ice shell covering that ocean runs somewhere between 9 and 15 miles thick. Underneath it, the ocean itself may plunge to depths of around 60 miles. And altogether it's believed to hold more than twice the volume of water found in every ocean on Earth. A moon smaller than our own, sitting in one of the coldest parts of the solar system, quietly holding the largest reservoir of liquid water we know of, anywhere. But an ocean by itself doesn't guarantee life. Life needs energy too. And down there, in the permanent dark beneath the ice, sunlight simply doesn't exist. So where would that energy come from? Here on Earth, we actually have an answer already sitting on our own seafloor. Deep in the pitch-black ocean, far below where sunlight ever reaches, there are places called hydrothermal vents, cracks in the seafloor where mineral-rich, superheated water gushes out from the planet's interior. Around these vents live entire ecosystems that have nothing to do with sunlight. Blind crabs, strange tube worms, colonies of bacteria, all of them surviving purely off chemical energy bubbling up from below. Planetary scientists suspect Europa could have something similar. If tidal forces are heating the icy shell, they're very likely heating the rocky seafloor underneath the ocean too. And if that rock is warm enough, water seeping through it could erupt as hydrothermal vents, just like the ones on Earth, pumping heat and chemical nutrients directly into Europa's ocean. Some newer models even suggest these gentler vent systems, cooler than Earth's dramatic black smokers but far more widespread, could remain active for billions of years. That's an extraordinarily long, stable window for something to evolve. So now Europa checks off two of the big requirements for life: liquid water and a source of energy. What about the third piece? Chemistry. This is where things get even more interesting, because Jupiter's brutal radiation, the same radiation that would be lethal to any astronaut standing on Europa's surface, might actually be helping. As charged particles slam into the icy crust, they break apart water molecules and produce compounds like oxygen and hydrogen peroxide. Estimates suggest Europa's surface generates roughly 1,000 tons of oxygen every single day. Enough, in theory, to support around 1 million people if it could somehow be captured and breathed. If even a fraction of these oxidants slowly migrate down into the ocean through cracks and moving ice, they could serve as a chemical energy source for anything living below, similar to how oxygen fuels respiration in animals here on Earth. On top of that, spectrometer data from Galileo detected signs of salt on Europa's surface, likely sodium chloride, ordinary table salt, giving parts of the moon a faint yellowish tint. And in 2023, the James Webb Space Telescope detected carbon dioxide concentrated specifically in one of Europa's chaotic terrain regions. Strong evidence that carbon, one of the essential building blocks of life, is present in the ocean and occasionally reaching the surface. Water, energy, chemistry, Europa has all three. And when astrobiologists rank the most promising places to look for life in our solar system, Europa now consistently sits near the very top of that list, ahead of Mars, ahead of Saturn's moon Titan, ahead of almost everywhere else we've looked. Of course, having the right ingredients doesn't prove anything is actually alive down there. So scientists went looking for something more direct. And in 2012, they found it. Astronomers pointed the Hubble Space Telescope at Europa and detected faint ultraviolet glows near the moon's south pole, a signature consistent with water vapor being blasted out from the surface and broken apart by sunlight. In other words, Europa appeared to be venting material from its ocean directly into space. Lorenz Roth, a researcher involved in the discovery, described it simply as water vapor erupting from plumes on Europa's surface. If confirmed, that would make Europa only the second moon known to actively spray its subsurface ocean out into the void, following Saturn's moon Enceladus, which does something remarkably similar. Interestingly, these plumes seem to appear when Europa was at the farthest point in its orbit from Jupiter, not the closest. That detail actually makes sense once you remember the tidal flexing we talked about earlier. When the moon is stretched to its maximum, cracks in the ice may pull open just enough to let pressure escape. As Europa swings back closer to Jupiter and the stretching eases, those same cracks clamp shut again. The moon appears to breathe in and out on a schedule tied to its own orbit. Then, in 2018, researchers went back through decades-old data from the Galileo spacecraft and found something remarkable that had been sitting there unnoticed the entire time. During a flyby back in 1997, Galileo had briefly passed through a sudden change in Europa's magnetic field and a spike in charged particles, lasting only a few minutes, but matching almost exactly what you'd expect from flying straight through a plume of ionized water vapor. Without realizing it at the time, Galileo may have flown directly through evidence of Europa's ocean, more than 20 years before anyone noticed. So if there really are cracks venting material from that hidden ocean straight into space, the next obvious question practically writes itself. What else might be coming out with the water? That question is exactly what two brand new missions are being sent to answer. NASA's Europa Clipper launched on October 14, 2024, and is currently on its way to Jupiter, expected to arrive around 2030. Rather than orbiting Europa directly, which would expose it to lethal radiation for extended periods, Clipper will orbit Jupiter itself and perform roughly 50 close flybys of Europa, some passing as low as 15 miles above the surface. Onboard is a suite of 9 scientific instruments, the most advanced set ever sent to study an outer solar system world. Clipper carries a radar sounder capable of sending radio waves straight into Europa's ice shell to map its structure and search for pockets of water. It carries magnetometers to measure that telltale magnetic signature and confirm just how deep and salty the ocean really is. And critically, it carries a mass spectrometer and a dust analyzer designed specifically to fly through any plumes it encounters and directly sample what's inside them. Water, salts, organic molecules, whatever is there, Clipper is built to catch it and analyze it on the spot. Meanwhile, the European Space Agency's JUICE mission, short for Jupiter Icy Moons Explorer, launched back on April 14, 2023, and is also en route, expected to arrive in 2031. While its main destination is Jupiter's largest moon, Ganymede, JUICE will perform 2 flybys of Europa along the way, adding its own radar, spectrometers, and magnetic field measurements to the growing picture. Together, these two missions represent humanity's most serious attempt yet to answer a question that's been building for almost 50 years. Neither spacecraft is designed to detect life directly, but both are designed to tell us, with real data, whether the conditions down there could actually support it. And if they come back with strong evidence, a warm, chemically rich, organic-laden ocean, the next step almost writes itself. A future lander, perhaps one that drills a short distance into the ice, or even, decades from now, a probe that melts its way down and swims. For now, Europa remains exactly what it's been since Voyager first photographed it in 1979. A locked door we can see, but haven't opened. Somewhere under 20 miles of ice. Warmed not by a star but by the crushing grip of the largest planet in our solar system, there's an ocean that has been sitting in total darkness for longer than complex life has existed on Earth. We don't know what, if anything, lives there. But for the first time in history, we actually have the tools on the way to start finding out. And maybe that's the real takeaway here. We spent centuries searching the sky for other worlds like ours, warm, sunlit, familiar, but it turns out one of the most promising places for life in the entire solar system might be a frozen moon that never sees daylight at all, proving that life, if it exists out there, might not need our version of a perfect world. It just needs water, warmth, and time. And Europa has had all three for billions of years. Thanks for watching, and I'll see you in the next one.